So welcome to Astrophysics. This is the optional unit in Unit 5 in AQA A-Level Physics. We're going to look at all kinds of exciting things to do with astrophysics, but we have to start off with some good old-fashioned analysis of lenses and how they work, so we can move on to looking at telescopes. We're going to remind ourselves about GCSE knowledge about lenses and how images are formed in convex and concave lenses, and then we're going to try and come to a formula which relates to things that you'll have talked about a little bit at GCSE, the image distance, the object distance, and the focal length of the lens. So just to remind ourselves about lenses, here's a simple kind of diagrammatic version of a lens. It's a convex lens, it's thin at the edges and wider in the middle. Here's light as if it was going through a prism. It's going to refract here and refract again as it comes out in the same direction. One going down the normal line through the middle carries straight on. So there's our simple idea of how a convex lens works. Okay, but real lenses obviously aren't like this because we'd end up with the light meeting at different points. Okay, real lenses are made of more and more little prisms, if you like, until it just becomes a curved surface. This curved surface is actually part of a very big sphere, which is why these are called spherical lenses. Okay, key terms that we need so that we can talk about lenses and all know what we mean. The optical centre of the lens here is in the middle. The axis down here, called the principal axis. The focal point, or strictly speaking, the principal focus here. This is where the light meets, as long as it's travelling in the first place parallel to the principal axis. If the light's coming in at an angle, it won't reach the principal focus. It will meet at some other point at approximately the same focal length, but a different point. And here's the length, the focal length of the lens, the distance from the optical centre to the focal point. So if we're clear on those points, we can talk about lenses and we all know what we mean. So hopefully you'll be familiar with this kind of diagram from GCSE of how we form an image in a convex lens. Okay, we've not bothered to draw the whole lens because that just gets in the way. We just draw some little curves at the end to show us what kind of lens we've got. Two rays we have to draw. One ray goes parallel to the principal axis. This ray will go down through the focal point over to there. The second ray goes straight through the centre of the lens, the optical centre of the lens, where these two beams meet. That is where the image is formed. Okay, properties of this image you'll remember probably from GCSE. This is diminished because it's smaller than the object. It's inverted, i.e. it's upside down, and it's real because the two beams actually meet there. If I put a piece of paper there, then I would actually be able to form an image onto that paper. Okay, the distances that we need to be able to talk about to do the equation are the object distance and the image distance. Okay, symbol for the object distance U, symbol for the image distance V. Notice that the object distance is taken to be positive, it's to the left of the lens, and the image distance is taken to be positive, it's to the right of the lens. Okay, the signs will become quite important for us when we get to the equation. Okay, just a little point to notice there, all of the beams will meet at this point. Okay, it's just quite hard for us to show where a beam that was travelling, say, in that direction will go to. Okay, but it would go through the same point. So we've got a little animation here just to show us what happens. What we can do is we can move the object to different distances. You'll notice the closer the object gets to the focal point here, the further the image gets away and the bigger it gets. Okay, so there's a very magnified image. This is the diagram we'll have done at GCSE for a slide projector. Also notice if we go too far and we go past the focal point on the left hand side of the lens, then we get to the stage where we form, these two beams are never going to meet over there. So we go back on the same side and form a magnified image. This is a magnifying glass diagram. Okay, so what you haven't done at GCSE is you haven't done an equation to actually work all this out. You may have done some scale diagrams, but you won't actually have been able to work it out without drawing a diagram. This is a little bit of algebra. You don't have to worry too much about that. You just need to understand the formula that we get to at the bottom. But just to show you, here's our object. HO is the height of the object. We draw the two beams, as we mentioned before, parallel to the axis through the focal point, one that goes through the centre of the lens. Okay, here's our focal length F of the lens. Okay, here's our image. This image has got a height which we call HI, the height of the image. Okay, how can we relate all these numbers together? Well, we have to do a little bit of similar triangles. So there's our object distance, image distance. Let's look at this blue triangle. It's similar to this blue triangle. So if we know the ratio of the heights, we'll know the ratio of the lengths as well. Well, we know the ratio of the height is HO over HI. Therefore, that's the same ratio as the ratio of the lengths, U over V. So here's one equation. We need to look for two more similar triangles. So we've got this one and this one. Again, okay, that goes through the axis there in a straight line, so these must be similar triangles. Okay, this height is the same as that height, so I've still got HO over HI. But now these lengths, this is F, and then the slightly tricky one, this length here is V minus F. So two equations, we can do the algebra. I'm not going to talk you through this, but you can have a look at it if you'd like to. But it gets us to this equation, 1 over U plus 1 over V equals 1 over F. Quite important to notice that this is taking U to be positive on the left, V to be positive on the right, and F for a convex lens is a positive number. Okay, also you remember that the magnification formula from GCSE was the height of the image divided by the height of the object, and we've set up there that's also V over U. Just to show you, it'll also work with a concave lens. Okay, notice now we've got the focal length on the left. The equation is exactly the same, it just means that we get a negative focal length here. So we can draw the diagrams in the same way, but this beam that's gone parallel will come up as if it's come from this focal point on the left hand side of the lens. Still draw the other one straight through the optical centre. Okay, still got an object distance there, but now the image distance is back on the same side of the lens. Okay, everything will work exactly the same. You'll end up with a negative value for V because the image is back on the left hand side of the lens, and that will come because you've got a negative value for F. Just one important thing to notice, that when you get that negative value for V, that means that V over U will be a negative answer. A negative magnification, remember, does not mean it's got smaller. Okay, the magnification is more or less than 1. That's what tells you whether it's smaller or not. The negative tells you which way up the image is, and actually a negative value tells you it's the right way up.